Today we will be summarizing lessons 3 and 4. Lessons 3, we looked at area of irregular shape. And lesson 4, we apply our knowledge of perimeter and area to solve real world problems. So our goal today is to determine the area of irregular shapes and related real world problems. In the past, we looked at composite shape, meaning you have a combination of these regular shapes or irregular shapes. We found shaded regions. We look at fraction of a shape and the question we'll be looking at today is applying area to find the cost to tile a floor. So for today, you'll need your formula sheet. This one you have. One is a formula for reference. You'll probably need a calculator and a pencil or a pen. Reviewing assignment 3, we'll be looking at 3 questions of irregular shape. First one is here, then we have one has 2 semicircles, a rectangle. Next one has a triangle, a semicircle, and a rectangle. And then we'll look at one real world problem, tiling the floor of a kitchen. You have to find the cost, tile the floor of a kitchen. And you're given certain conditions. Okay, so that's our lesson for today. So let's look at the first question. Find the area of each of the figures shown below. Now, there were 3 here. So there's 1, then we have the next 2. In your booklet, they're all on 1 page, but just for space, I've divided them into 3 separate 2 pages. Question 1, you asked to find the area of the figure, of this figure here. Now, remember, when we have these lines at the side, it means that this dimension here, these ones here, are equal. So how do we find the missing one? So we have 1 missing dimension here, 2 missing dimension, and we have this 3rd one here. So we need to find them all, or depending on how we go about approaching this question. Now, there are 2 ways of approaching this. You can find divided the section is 1 section here. So we have 2 rectangles, or you could divide it up here and have another 2 more rectangles by removing this one here. Either way, you'll need to find the area for 2 sections. I'll go ahead and I'm going to divide it up into exactly here. So I have one area 1, and we have area 2. The total area will be adding the area of both of these sections. Now, to find the area 1, I need to know this is a rectangle. I need to know the width. I know the length, but I don't know the width. Now, what is the width? We can find that because this total width here is 12. Since this is 90 degrees, it means that these lines are parallel. So therefore, the distance from here to here is the same as on 12 kilometers. So if this is 12, these 2 here are equal. This has to be 6 kilometers. The total area is equal to the area 1 plus area 2. Area 1 is length times width plus area 2 length times width. Our length here is 20, so 20 km multiplied by 6 km. So 20 times 6, now that will give us 120 square kilometers, plus our length here is 50 times 6, which works out to be, what, that's 300 square kilometers. We have 50 times 6. It's giving 120 square kilometers. Plus 50 times 6, we said is 300 square kilometers for a total of 420. So total area okay, that's question 1. Let's move on to the second question. To find the total area, we're already given these 3 sections. We're given the width, and we're given the length from here to here, but we don't know the dimensions here are not given. So we need to deduce these dimensions. Now, this is half of a circle, called a semicircle. So we have a semicircle here, we have a semicircle here. And we also have another one here. In reality, put these together because they're identical dimension would be one circle, but we'll find the area for each one. Now we have here, we have a rectangle. So we have a rectangle. So the first step you would like to do is to determine what kind of shape we have. Once we know the shape, we will go to a formula sheet, if you can't remember it, to find the area using the formula sheet now to discover or deduce our area. So the total area for this irregular shape, we can conclude, so we say the total area is equal to 2 times the semicircle. So the area of semicircles plus the area of the rectangle. Now, the area of a semicircle be half the area of a circle. So we have pi r squared, so area divided by 2. Because area of the rectangle is length times width. the area of a circle. Oops, let's write it out here a little bit. Is pi times the radius to the power 2. We know pi, but we don't know the radius. Now, how can we find the radius? Now, I'm going to remove these from here, so we know what they are now. This is 200, so we know the length here is 200. But the width is 80, so it's given here as 80. This 80 meters is the length of the diameter of the circle. So this is 80 here, which is a diameter. Now, from here to here is half. This is the radius. So this will be my radius. And we know the radius is half of the diameter. So the radius now will be 40. So this will be 40. Yeah? Maybe here is 40. So radius equal 40 meters. So we can put 40 here, square. Which is 2 times pi for the square. Now we're going to divide it by 2. Now you notice you multiplying by 2 divided by 2, it will cancel out. So will remain with pi r squared, because 2 halves of a circle makes a whole. So in reality, you will find the area of a circle. So we can cancel out these 2 here. So we're left with pi r times 40 squared. Now length times width. Now we know our width here. We know our length is 200 times 80. So we have 200 meters multiplied by 80 meters. So this gives us, now put our calculator out here. Okay, that will work. I'll just move this over here a little bit. Just like to show you what I'm doing. So I have 40 square, so I'll put 40 square, 1600, then I multiply by pi. So this is pi times 1600. I multiply that now by pi. I'm going to use my pi button. So this gives me 5026.54. It goes on. This gives me meter square plus 200 times 80 will give me, we have 3 zeros here. We have 1, 2, 3 zeros, 16,000. Now add 16,000, 1, 2, 3. Gives me a result of 21,026.55 meters square. So that's my final answer. My total area so the total area for composite shape is 21,026.55 square meter. So recap, step 1, you want to identify the different shapes within this composite. Then indicate the different measurement. If you don't know, you have to determine it. Then we use the formula for each one of them. So we have rectangle length times width, circle is pi r squared. Then we substitute our given values into our formulas and do our calculation. Okay, the next question, you're to find the total area for this composite shape. As I mentioned, you need to identify the different shapes. So I'm going to put the line right down here, a dotted line. So now we have a triangle here. We have, and this would be a square because 30 times 30 is square. And here we have half a circle. Which we call a semicircle. Our task now is to find the area of half the circle plus the area of the square plus the area of a triangle. So we can record that as total area equals area of half a circle plus area of square plus area of triangle. Then we go to our formula sheet. We said area of a circle is pi r squared. Area of a triangle is half the base times height. And the area of a square is length times width, or side squared. So we'll rewrite each one of these here. So we have pi r squared, but we need half of it. Okay, because we're gonna find half of that. Another way of writing this here seems that it could also be half pi r squared. Plus area of the square is length times width. Area of a triangle is your base multiplied by the height divided by 2, or half the base times height. So let's look at each section. Now I'm going to remove this here. We know this is half a circle. We need to find the base for the triangle. The base of this triangle will be 30. It's the same This line is parallel to the other line here, so give me 30 feet. The height, we need to find the height. And we also need to find the radius here. Imagine this is a circle, and you complete the circle here. So this will be our diameter, which is 30. So 30 feet is the diameter of the circle. So the radius will be half of 30. So this will be 15 here, 15 over here. This will be 15. So this dimension from here to here is 15 feet. So we can conclude here the radius equals 15 feet. The length .30, the width equals 30, the base of the triangle. So this will be our square, for a square. The base is 30 feet. And our height now, we need to find the height. Notice they give us a dimension from one end to the other end of this composite object. Tell us it's 70, but they give us the height of this. So we know this section here is 15. Now, from here to here is 30. So this length here would be 70 minus 30 minus 15. So this is going to give us 70 minus 30 minus 15, which works out to be what, 25? So 25 feet. So the height equals 25 feet. Now this would apply to a triangle. So now we have all of our dimensions. We'll take our dimensions and substitute into our formulas. So we know pi, the radius is 15. So we can put here, this is for a circle, 15 squared. Remember to divide it by 2 because it's half of the circle, because we don't have two circles in this case. Plus the length times the width, which is 30 times 30. That's base, which is 30, times the height, which is 25. Divided by 2. I'll just put a bracket around that. Now it's time for our calculator to do its work. Now, I would suggest, depending on what kind of a calculator you're using, to begin with 15 to the power 2 squared. Now, if you have a graphing calculator, you can do the entire process. And in this case, if I were to show you how we do it, what I meant by that is that I'll say pi, open bracket, 15 to the power 2 divided by 2. This is what it will look like. Open bracket, pi, open bracket, now 15 squared, close bracket. And that will give me 706.85. So 706.85 858 divided by 2. Another way of doing that is you could start out with 15 squared. Now, some of you, this is what you may have to do, times pi. And you'll end up with the same result. Then you divide it by 2 to give you 353.43 square feet. Now plus 30 times 30 give us what? 300. So 900. So there are 900 square feet. Plus 30 times 25. So we have 30 times 25. $750, but you're dividing it by 2. So 750 divided by 2 gave me 375. Put them all together. We add these up. We have 375 plus 900 plus 353.43 gives me a measurement of 1628.43. So the total area is 1028.43 square feet. So our total area is 1,628.43 feet. Okay. We'll look at a couple of other questions that are within assignment 3. Just to give you an idea. Now, this question here, find the shaded theory of the shaded region. Now, you basically could do a subtraction. You find the area of the square, because this is a square, so we have 8 centimeters all around. And we have a circle inside. And he has to find the area of the shaded region. So the area of a shaded region will be the area of the square minus the area of the circle. So area of the square, so the shaded area, or the, so we have shaded area is equal to the area of square minus area of the circle. Area of the square would be length times width, or square times side, and the area of the circle would be pi r squared. We already know the length here, and the width is the same. the radius of a circle is half its diameter. The diameter is 8. If you were to complete here, be 8. So this will be 4 centimeters. So the radius is equal to 4 centimeters. So now we can substitute our values into our formula. Length times 8 times 8 minus pi 4 squared. So 8 times 8 is 64 minus, now we need to do a little bit of calculation here, which is 4 squared times our pi, 50.27. So 50.27 seems square. Now I'm going to subtract 64. Give me 13.73. So 13.73. So shaded area. The other question is similar, and I'll let you complete this one here. Just remember that the radius is 12. So the radius is 12 feet. In this case, you find the area of the circle, area of the square, and you subtract the area of the square from the area of the circle. So if you were to write this one out, so shaded area is circle, which is a reverse of this one here, minus the area of the square. So if you work that out, circle is pi r squared minus length times width, which is the radius is 12 for the circle. Now the length and the width is 10 times 10. Let's give us what pi, 144 times pi will give us 452.38 minus 100 for a final answer of 352.39 square feet. Final question in this section I'll look at is this wonderful one here. A tricky one, but I like to go over this question with you. We need to find the shaded area. Now, the shaded area will be area of this rectangle here minus the area of, we have 2, 4, 6, 8 circles. Imagine you have a piece of paper or a box and you punch holes in these boxes. What's remaining would be these shaded areas. You have 8 holes in it. Now, or you have a board and you punch 8 holes in there. But the question is, we know the dimension of the length, the width here, but the width length isn't given directly, so we need to determine it. But what do we know of a circle? We know the circle, the diameter are the same. Now there are 2 circles in here. They come from end to end. Therefore, their diameter would be the same. Now this is 6 centimeters. So halfway through here, it'd be 3. Well, that's given, but also the same would go forward over here. So it'd be 3, 3, and 3. So this is 3 centimeters, 3 centimeters, 3 centimeters. And if you go over here, from that, we can determine that the length of this rectangle will be 3 plus 3 plus 3 times 4 is 12. So we 12 centimeters. Even though it's not given, we can determine it. From here now, we know the length. Let's write our general form here. Area, shaded area, is equal to the area of rectangle minus the area of 1, 2, 3, 4, 5, 6, 8 circles. The area of the rectangle is length times width. 8 circles would be 8 times pi r squared, because this is a circle, so it'll be 8 times each circle. The length here is 12, so we have 12 multiplied by 6, 8. Now, the radius, interesting now, since the diameter is 3, our radius is 1.5. So radius, so we can put that here, radius, go 1.5 centimeters. Because it's half. I can write it here, 1.5. So it's pi times 1.5 to the power 2. 12 times 6, which just gives us 72. Now, let's work this guy out here. We'll do it separately. Let's do the inside first. So 1.5 to the power 2. 1.5 squared give us 2.25. So this is pi okay, now I'll multiply that by pi. Oh, no, I did not do that. So 1.5 squared multiplied by pi. 7.068. So continue pi minus 8. We have 7.0. We can run it up to 7, but I'll leave it as it is there because it looks like it's going on for a long time. So I don't want to round it. There are 8 circles. 1, 2. So I multiply by 8. Okay, there's a number of circles here. There are 8 circles. We can multiply by 8. This works out to be minus 56.548 goes on 72. Now minus 72, or the answer is 15.45 square centimeters. So my final answer (15.45 centimeters). Now we're going to one final real-world problem, and this will be found in lesson 4. The question, you would like to lay down tiles in your kitchen. You're going to hire an installer to perform your work. The kitchen's floor plan is given here. If the area is not shaded is where you'll be putting the tiles. Where the cabinet will be located, that will not be tiled. So your goal is to find how much tiles you need to put in the kitchen, and also how much it will cost for labor. So these are some conditions you're given. Tell us you don't want to put tiles under the cabinets. So so there's no tiles here. The tiles are 1 by 1 square foot. So there's 1 square foot. The tiles are sold in boxes of 8 tiles each. You cannot buy a partial box, so you have to buy an entire box. And each box of tile of 8 costs $15.99 plus tax. So you have to add your taxes to it. In Manitoba, our tax is 12%. But there's a labor cost. It costs you $60 per hour for every 50 square feet. Anything less than 50 will round up to an hour. But for this tax here, it's only the GST, which is 5%. This is plus 12%. What is the total cost to complete this job? Overall, we can conclude that the total cost going to be equal to the cost for tiles plus labor costs. Now, to find the cost for the tiles, we need to find how much tiles we need. And how much tiles we need to be multiplied by, find how many boxes of tiles we need. Actually, we need to find how many boxes of tiles we need, and we multiply that by the cost for each box plus your tax. Then our labor costs we need to find based on how many tiles we need. Now, to determine how much tiles you need to find the area of your floor that has to be tiled. So the number of tiles, so we can let's do the first one, the cost of tiles. Number of tiles so the number of tiles will determine that by the area of the floor to the area of the floor minus the area of the cabinet. Now, each tile is 1 foot by 1 foot, so there's 1 square feet. So we have divided by 1. In this case, we don't need to do anything because divided by 1 will remain what it is. So essentially, the number of tiles will be the area of the floor minus the area of the cabinet. That's the first thing we need to do. So let's find the area to be tiled. So area to be tiled is equal to the floor area. So we have the floor area here. cabinet area. To find the area of the floor, now there's a composite shape here. So we have to go about finding the button. So ignore for a moment, this is not a cabinet here. We just looking at the entire floor, ignore the cabinet. Imagine there's no cabinet here, the floor is bare. So we need to find the entire area here. So now this will be, now there's a section here, we need to section off here. This is a rectangle, so 8 times 1, which gives me 8 square feet. Okay. Now, the area of the rest of the floor will be, now this is 1, so this will be 9 square feet. Over here, this is 9. The entire length here would be 8 plus 15. So from here to here, and this is 15. That will give us a length of 23. So we have a total length of 23 here. So the floor area will be 9 times 23. So we have 9 times 23 plus 8 times 1, which is 8. So let's record that here, the area of the floor, which is 9 times 23 plus 8. The area of the cabinet will be these two sections here now, which is 15 times now. This will be 2 here, because this is 15 times 2, and this section here is 2 times 2.5. So we have 15 times 2 plus 2 times 2.5. So I'll record that here. We can conclude then that the number of tiles will be equal to 9 times 23. Let's work this out. 9 times 23 plus 8 gives us 215. So we have 215 square feet is the area of the floor, and the cabinet would be 15 times 2 plus 2 times 2.25. Gives me a dimension of, now, I did a miscalculation there. Okay, 15 times 2 plus 2 times 2.5. Give me 35. So all of this is 35 square feet. For this. So number of tiles, so we can get that here, number of tiles. Is equal to 180. because if you can do this divided by 1 square foot, right? So 180 tiles. That will be equal to number of tiles. So number of tiles we need is 180. Now the cost for the tiles, we need to find that. That's what we're getting into here. So the cost of tiles is equal to, here we have the number of tiles divided by 8. So number of tiles divided by 8, because it tells us here that there are 8 tiles in each box. Now, number of tiles divided by 8, when we're going to multiply that by the cost for each box of total. Plus tax. So number of tiles here is what? 180 divided by 8 multiplied by 1599 plus our taxes. We'll do it at the end. So number of tiles. So we have here, so number of boxes of tiles, I should say here. So this would give us how many boxes of tiles? Here we'll need, okay, now it tells us we can only buy whole boxes, right? We can't buy, so we have to do some rounding here. So we have 180 divided by 8, 22.5. Now we cannot buy 22.5 boxes, we need to round up. So it'll be 22.5 so we need to round up. Put it aside here. So we're rounding, because it's like rounding. So they give me 23 boxes times 15.99. That worked out to be so 23 times 15.99, 367. That's before taxes, plus 12% tax. Now we'll do it separately, show you how to do the calculation separately, and then we'll, if I want to find 12% tax here, it'd be 12%. It will be 12% of $367.77, which worked out to be, now you have to use our calculator here. There's 3 times 12 divided by 100, give me $44. And 13 cents. Now we can add $14.30 here. Now plus 367.77, and we got 367.77. We're going to be $411 and 92 cents. Now we could have done this separately, do it all in one by do your calculation is up here. Okay, this might work. So instead of plus 12%, I'll multiply this by 1.12, because that is, I mean, including the 12% plus the original amount. So I'm going to go back to my questions. 15.99 times 23 times 1.12 give me 411.90. Which is the same you got by doing it separately. Now this is the cost for the tiles. Now the labor cost, we need to find, so the cost for tiles, we can record that as 411. I'll just put it up here, 90, plus labor cost. Let's do the labor cost here. So labor cost will be equal to, now they'll tell us you need to pay the person $60 per hour plus the GST, but how many hours will you need depending on the square feet? Now there's 180 square feet of area to be tiled. We got that from original question. So since we have 180 square feet of tiles, it means you need, the person needs to work for 50 hours. Sorry, for 4 hours, because it's 50 square foot per hour. So since you have to round up to 200, there are 200 square feet in this case for labor costs. It will take 4 hours. So it will take for 4 hours, multiplied by the cost per hour, which is $60, plus 5% tax. So it's going to be 4 times 60 multiplied by 1.05. I'll do the shortcut, 1.05 meaning the GST. So what do we get here for calculation? Four times 60 is 1.05. Actually 252. So now we have our labor cost is $252. So we can conclude our total cost for tile plus cost for labor cost for tile is 411, so I highlight that. So there are two costs, so labor cost and cost for tile. $411.90 plus cost for labor is $252. It works out to be $663.90.